To properly install a section of 3/4-inch electrical metallic tubing, or EMT, from a beam to a control box 20 feet below, you must adhere to the National Electrical Code, or NEC, requirements for support. NEC Section 358.30 dictates the support and securement of EMT. Specifically, it states that EMT must be supported and secured in place at intervals not exceeding 10 feet. Given the scenario where the conduit run is 20 feet vertically and there are no intermediate supports, a method of support is required to meet the NEC code. One effective method involves installing a strut vertically. The strut acts as a continuous support structure. The strut can be secured to the beam at the top and anchored near the control box at the bottom. After the strut is in place, the EMT conduit can be attached to it using appropriate EMT straps. These straps should be spaced according to NEC 358.30, which is at intervals not exceeding 10 feet. In this particular scenario, the best practice is to install 3 straps. One strap located near the top, close to the beam attachment point, a second strap in the middle, approximately 10 feet down from the first strap, and a third strap near the bottom, close to the control box. Ensure that the straps are properly sized for the 3/4-inch EMT conduit and securely fastened to the strut. Using a strut and EMT straps provides a robust and code-compliant solution for supporting the EMT conduit, ensuring the safety and reliability of the low-voltage data cabling installation. Additionally, consider these points. Firstly, ensure the strut is adequately sized to support the weight of the EMT and the cabling. Secondly, use appropriate hardware for attaching the strut to the beam and the floor, considering the materials of both the beam and the floor. Thirdly, when installing the EMT straps, avoid over-tightening them, as this could damage the conduit. Fourthly, ensure the EMT is properly grounded according to NEC requirements. Fifthly, consider using a flexible conduit section near the control box to allow for movement and prevent stress on the EMT. Sixthly, check local codes and regulations, as they may have additional requirements beyond the NEC. Seventhly, when cutting the EMT, use a proper conduit cutter to ensure a clean, burr-free cut. Eighthly, ream the cut ends of the EMT to remove any sharp edges that could damage the cabling. Ninthly, use appropriate fittings and connectors to ensure a secure and watertight connection between the EMT and the control box. Tenthly, label the EMT conduit to indicate that it contains low-voltage data cabling. Remember to always prioritize safety when working with electrical systems. Disconnect power before making any connections and follow all applicable safety precautions. The selection of EMT straps depends on various factors including the conduit size, the material of the mounting surface, and the environmental conditions. The most common types of EMT straps are one-hole straps, two-hole straps, and standoff straps. One-hole straps are suitable for light-duty applications and are typically used when the conduit is supported by a single fastener. Two-hole straps provide greater stability and are used when the conduit requires more secure support. Standoff straps are used to create a space between the conduit and the mounting surface, which can be useful for preventing corrosion or allowing for air circulation. When selecting EMT straps, it is important to choose straps that are specifically designed for use with EMT conduit. These straps will typically be made of galvanized steel or aluminum and will have a smooth, rounded surface to prevent damage to the conduit. It is also important to choose straps that are the correct size for the conduit being used. Using straps that are too small can damage the conduit, while using straps that are too large can result in a loose and unstable installation. In addition to selecting the correct type and size of EMT straps, it is also important to install them properly. The strap should be securely fastened to the mounting surface using appropriate fasteners. The strap should also be spaced evenly along the conduit run, with a maximum spacing of 10 feet as per NEC 358.30. When installing EMT straps, it is important to avoid over-tightening the fasteners. Over-tightening can damage the conduit and can also make it difficult to remove the straps later on. It is also important to avoid using excessive force when bending or shaping the conduit. Excessive force can damage the conduit and can also make it difficult to install. By following these guidelines, you can ensure that your EMT conduit installation is safe, reliable, and code compliant. The strut referred to earlier is often called unistrut, which is a brand name, but it is also a generic term used to describe a metal framing system that is used to support various mechanical and electrical components. The strut channel is typically made of steel or aluminum and is available in a variety of sizes and shapes. The strut channel has a series of holes or slots that allow for the attachment of various fittings and accessories. The fittings and accessories can be used to create a wide variety of support structures, including equipment supports, pipe racks, cable trays, and conduit supports. Strut systems are commonly used in commercial and industrial applications because they are strong, versatile, and easy to install. They can also be easily modified or expanded as needed. When selecting a strut system, it is important to consider the load that the system will be supporting, the environmental conditions, and the specific requirements of the application. It is also important to choose a strut system that is compatible with the other components that will be used in the installation. In this case, the strut system provides a solid backbone for the EMT conduit run, allowing for secure and code-compliant support, especially over long vertical distances where intermediate support is not available. The selection of the correct type of strut is important. There are different gauges of metal to choose, different lengths, and also different finishes for different environments. A thicker gauge strut might be needed depending on the weight of the cable that will eventually be inside of the EMT conduit. You must account for this weight and any potential future weight of the cables.